Okay, Adish, how are you doing?
I am fine.
Where are you from?
I'm from Pune.
Pune.
Yeah.
Okay. And did you give JEE, Adish?
No, actually, I am like I passed standard last year, and after that, I wanted to pursue mathematics. So I joined a BSc program at Pune University. But so last year also I gave ISI without any preparation. But so I tried one. So I gave one more try this year.
Great.
Great. And how much you think you got in UGA?
Actually, for UGA, I haven't calculated, but UGB, I think I've scored 4.5 questions there.
Oh, great.
Good. So, which area of mathematics you find most easy for you?
Actually, I don't find anything easy as such, but the most thing which I'm interested in is calculus, and yeah, so that is the thing which interests me the most. And uh, apart from that, combinatorics is also one thing which fascinates me.
In calculus, specific like integral calculus or differential calculus?
Uh, like I don't like to manipulate things, like so integration better is differentiation. Like I like to analyze things more than calculate.
Great.
Okay. So, sir, you ask a question then.
Okay, well, start with the same question.
Yes, sir. Yes.
Okay, so Adish, it's a very straightforward question. So fx is equal to x cube minus 3x minus 1. You need to comment about the roots. So one is real, non-real. The second is rational, irrational. How many rational, how many irrational roots?
So hmm, so can I think loudly?
Yeah.
So f of x equals x cube minus 3x minus 1. So as this is a odd degree polynomial equation, we know that there exists at least one real root. Now we have to check whether the other two roots are complex or they are real. Hmm. Check for just root. Minus 3 and 8 minus 3 over 4. Okay. So there will be a root over here. The 0 is coming over. Yeah, so I think there are 3 real roots.
Okay.
So can I explain why?
Yeah.
Okay, so basically I am trying to use here intermediate value theorem. And so basically I plugged in some values, like I plugged in f of 2. So f of 2 is basically coming out to be positive, and f of 1 is coming out to be negative. So there will have to exist a root between 1 and 2. Now I checked value of f of 0 and f of minus 1. Again there is a sign change, so there has to be a root in between them. And as I found out 2 roots, so as it's a cubic, all the 3 are real.
Okay. So, but don't you think checking these random values, okay, it is fine in this case, but if the coefficients are, I mean, very complicated, it is going to cause problems.
then I have to maybe check the derivative and see where it is increasing or try to sketch the graph. But
you should have checked the derivative straight away. Okay, anyways. Right, so 3 real roots. Perfect.
Yeah.
How about this?
Rational and irrational. I think, can we use your rational root theorem somehow?
Yes, you can.
So, if the root is a form, Q has to divide its into has to divide its coefficient. So the coefficients are 1. So one has to. I don't think it's a rational root.
Okay, can you reason?
Okay, so so basically, if it was a rational root, I could have written it in the form P over Q, where P and Q are integers and both are co-prime, like relatively prime. And now if I plug f of P over Q in the expression and I manipulate the expression a bit, I get that P must divide -1 or P must divide 1 and Q must divide 1, the coefficient of x cube. So this must mean that P must be equal to plus or minus 1. And when I plugged f of 1 or f of -1, it's not giving me 0. That means that such a root will not exist.
Okay, perfect. So just a counter question. So there's something called irrational conjugate theorem. If one of the root is of the form P plus root Q, the other is P minus root Q.
Yeah.
Right? So how can there be 3 irrational roots?
I don't think so. There can exist 3 irrational roots.
So you mean to say that for every odd degree polynomial?
No, wait. So can there exist? No, my claim was wrong. There should exist 3 irrational roots. Obviously, one can construct such a polynomial equation where the 3 roots are irrational. I mean, there is nothing wrong in that.
With rational coefficients.
With rational coefficient. No, that's. So, but the thing is, my question is that why do these roots have to occur in pair? Like this happens in quadratic, right? Why should it happen in cubic? The same thing.
So if in cubic one root, a cubic with rational coefficients. So let us consider a cubic with rational coefficients. If one of the root is P plus root Q, can you comment the other root would be this, yes or no? This is a cubic with rational coefficients. One of the roots is P plus root Q. P and Q are integers. Let's say integers. Will the other root be P minus root Q? Yes or no?
Yeah, I think it should be.
Okay. Then if P plus root Q is one of the roots, then other root will be P minus root Q. Can there exist 3 irrational roots in a cubic?
No.
With rational coefficients?
Yeah. I don't think it will exist. But then where did I go wrong over the previous thing?
Okay, let me tell you. So basically, irrational conjugate theorem, it works when only when one of the root is p plus root q. So if one of the root is p plus root q, the other root has to be p minus root q if the coefficients are rational. Right, but there can exist three irrational roots which are not of the form this. Right, so this is going to definitely have three irrational roots because the rational root can only be 1 and -1, which are clearly not the roots. So there will be three irrational roots, but those irrational roots will not be of the form p plus root q. Okay, so if one of the root is p plus root q, the other has to be p minus root q if the coefficients are rational. Okay,
they are not of the form like, plus root q and p minus root q, obviously.
Sir,
Can we do a question from integration? Simple manipulation based question.
are you sharing, sir?
Yeah, I'll share. ADEESH, can we do a question on integration?
Okay.
One minute. You are given one integration sine cube x upon x from 0 to infinity equal to pi by 4. Is it visible?
Okay. Yeah, it's visible.
Then you have to find 0 to infinity sine x upon x. Maybe they're assuming this is something that should be given, and based on that you have to find this integration of sine x upon x dx. I think dx is missing.
Assume that this other integral exists first of all.
See, maybe this both integration cannot be done on with the normal ways that we do in our +2 standard. So that is why they have given 0 to infinity sine cube x upon x dx is equal to pi by 4. So if you are saying that you can assume that it can be integrable with normal methods, I doubt that. Okay.
So basically, I have to assume that this is integrable. I don't have to prove that sine x over x is integrable.
Yeah, you have to just try to do the calculation so that this integration that they are asking for comes in the form of this sine cube x upon x.
Like I'm not able to proceed with the standard methods.
Okay, no problem. So should we tell you this solution? I think we should go for next question, sir. Abhay, sir.
Yeah.
I think I have one question. ENC, maybe.
Yeah, you can continue.
Also, you said is okay with you.
Yeah.
Okay. So the question is that you are given 1, 2, 3, and so on up to 100 natural numbers. Okay, and you have to select 5 out of them so that no 2 are consecutive. So that no 2 of them are consecutive.
Okay, so like I have an idea. So out of this set, I want to create some bijection, some kind of a bijection to a simpler counting problem. So I will kind of design an equation. So basically, let xi denote the gap between the first element and the chosen element, first chosen element. So x1 denote the gap between the first element, that is 1, and the first chosen element. So x2 denote the gap between the first chosen element and the second chosen element, and so on. And x6, so we will have, and lastly, let x6 denote the gap between the last chosen element and 100, basically the last element of this set. So now, so I think I have this equation that x1 plus x2 plus x3 plus x4 plus x5 plus x6 equals, there are total 100 elements. So out of that, you're taking out 5 elements. So 100 minus 5, which is 95. So x1 plus x2 plus x3 plus x4 plus x5 plus x6. So that should become 100 with the constraint that x1 comma x6 is greater than or equal to 0, and all the other xi's are greater than or equal to 1.
That's correct.
Now I will transform this equation. So I will convert all the xi's greater than or equal to 1 into yi's, such that yi is equal to xi minus 1. So that will make my equation right hand side as I will have to add plus 4 to the right hand side, which makes it 99 on the right hand side. So I will have x1 star plus x2 star plus 1 so forth plus x6 star is equal to 99, such that all of the xi star is greater than or equal to 0. And now I'll have to just use the formula of the equation, the non-negative solutions of the equation to get the desired answer.
That's correct. That's correct. Any other way of doing this?
Other way, like basically this formula is another bijection between binary like ones and zeros, right? It breaks down to that. So I think I might be able to create another simpler bijection directly with the binary thing, or something like that. I don't know. Like it all boils down to by creating bijections.
Means which bijection? Like you said, 1 with 1 and 0. So
No,
could
no,
you please
I'm saying
elaborate?
this so my understanding of this equation is that basically when you are given an equation, linear equation in n variables, and you want to have you want to count the number of non-negative solutions of it. So what do? You consider the like you consider a bijection between, suppose, so I'll take an example. Suppose x1 plus x2 plus x3 is equal to n. You have got this equation, and so basically what I will do, I will construct a bijection uh, between n number of ones, between all the binary sequences which have n number of ones, and uh, two zeros. So all such sequences of length, binary sequences of length n plus 2, which contain n number of ones and 2 number of zeros. So I basically count those sequences and I get this answer. That is so basically what here we are also doing that, anyways this is getting reduced to some kind of linear equation, which can again be like mapped to another such binary sequences. So I think the problem boils down to bijection.
I think I have one another method I will tell you. Before that, I will tell you that question of sine cube. Can you write sine cube in terms of sine 3 theta?
Oh, okay. Yeah. So sine 3 theta is basically 4 sine theta minus 3 sine cube theta. So yeah. So out of that I can 4 sine theta minus 3 sine cube theta. So 4 sine theta minus 3 sine 3 theta over 3 is sine cube theta.
Yeah. Now you can take this as j or whatever, and you will be able to write this integration in terms of j at two places, one here and one here. Okay. Like this is sine 3x upon 4x. You can write this as sine 3x upon 3x, and 4 you can bring outside. So it will become kind of 1 upon 4j. Okay.
Okay.
Okay, I'll add one more thing. Swadesh, probably something for you to work upon at your place before we do the second round. So there's a very common, famous limit, sin x minus x upon x cube at extending to 0. So limit x approaches 0, sin x minus x upon x cube.
Yes.
So try to find this limit without LH rule and without expansion.
Okay.
For that other question, what I was thinking that you can think of that you have to place 5 red chairs and 95 white chairs in a row. Okay, 5 red chairs, 95 white chairs. All chairs are identical except for the color. Okay, and the condition is that no 2 red chairs should be consecutive.
Yes.
Okay, then I think this question and this question is same.
Yes.
Okay, now to make sure that no 2 red chairs are consecutive, I will keep 4 white chair outside. I will keep 4 white chair outside. So I will be having 5 red plus 91 white chairs. And this kind of arrangement can be done in 96 C5 ways.
Yes.
Okay, because you have 96 places, you have to place 5 red chairs anywhere. But now the problem was that there are chances that some of the red chairs will be consecutive. Now for that I have 4 white chairs. So between 2 red chairs, I'll put 1 white chair, 1 white chair, 1 white chair, and that is the answer.
Yeah.
Okay, this is kind of gap method actually. If you have seen that gap method, it is kind of that thing only.
No, actually, I knew one more bijection, but that is artificial. Like I have read principles and techniques in combinatorics. From that, I know 2 or 3 more bijection. But then the interviewer will ask in detail, like how do you get there, and then I'll probably not be able to answer. So I stuck to what I knew the best.
Okay, okay, great. I think this was very interactive interview, I will say. You're very expressive, I think, ADEESH.
And confident.
Big, and very confident also. So that's a very big
I
plus.
also make mistakes, right? I mean, that is
Mistakes are part of they're going to happen. They're bound to happen. So again, don't worry about it. But again, with the kind of preparation that you have, I don't think there'll be any hurdles. There should not be any hurdles. We'll have one more round of mock interview, ADEESH, before. When is your interview?
on 30th of June.
Okay, that is we do have some time.
Yes.
Sure.
Anything you would like me to work upon?
I don't think there is anything in particular. Just that I don't think. I mean, there were other students who I would have made comments upon, but I think with regards to you, I don't think. Just that whenever if the interviewer asks you about your favorite topic, if he asks, right, so you can be more particular about the subtopic. For example, you mentioned calculus. You could have mentioned differential calculus instead of calculus. Yes. So that the interview starts with the question which is in your domain. So
Yeah.
it would be a very wide.
Integral calculus, but the thing is that I am much more interested in finding whether the integral exists rather than evaluating the integral.
Yeah. So that's what. So if you say calculus, the interviewer may switch to integral calculus also. Right. So you don't want that. You want him to be asking you differential calculus. At least the first question. If he asks you what is your favorite topic, right? So that is one. The other is you should be knowing about what how you performed and what you did in UGA, UGB, right? So they will be having your copies with them at the interview panel, and they might ask you questions regarding what you've written.
Okay.
Right. So that is other thing. Otherwise, I think it was very smooth. How are you doing in your college?
Yeah, it's fine because the kind of mathematics which you learn, like the undergraduate, it is very different from 12th standard. It's all proof-based maths. So,
yes.
So it's like Olympiad. It's like continuation of all the Olympiad topics, number theory and all of it.
Great. So you like maths? You enjoy doing that?
Yeah. That's why I enjoy doing the pure side of things. That's
great. Thank you, ADEESH. I think it was great, and we'll have one more round.
Okay. Thank you.
All the best.
Okay, thank you. All the best. Bye.
Bye.